Okay.
to show your project.
Well,
okay.
we're going to start off with Chris because he has a robot, I believe, that he was going to show.
All right, Mr. Robinson, I want to see the robot.
Hey, Chris. Let's see.
Hello, I'm frozen. I'm there. Hello,
you,
everybody.
Chris. You may want to turn on your microphone. Yeah, there you are.
Yes.
All right, it's robot time.
Can you hear me now?
Yes.
And Ada Fruit just blew up.
We blew up. We're here.
Are you here? There you are. Okay, cool.
Yeah, go ahead, Chris.
Yeah. This is Mr. Walter here, and I'll go ahead and fire him up.
What would you like to do?
Hello, Walter.
Hello, Christopher.
How are you?
Marvelous.
Introduce yourself.
I'm sorry, Dave. I'm afraid I can't do that.
Okay. Do the robots.
I can do all of that.
All right. So this is little Walter. He's weighs about 60 or 70 pounds. Steel frame. He's powered by 2 DeWalt drill motors, which I probably wouldn't recommend to anybody. He's 2 years of labor, and probably the coolest thing he does. I mean, he's got all the standard things. He's powered by 2 propellers. He used to be powered by just a wealth of pickaxe chips. I think I had 6 or 7 pickaxe chips on it at one point. But he's got all the standards. Here are his encoders. If my camera will catch up. He has 2 encoders, 1 on each wheel. These are 88-hole encoders, so 352 counts. So he can just about make 1-degree turns. He's got probably his greatest feature is a Wii camera and laser setups. So he's got a nice powerful laser and Wii camera, and because of the triangulation, he can judge distance, and then he can also use the Wii camera itself as an infrared beacon tracker. So he can track an infrared beacon, which is docking, follow the leader, hide and seek, etc. And then he's got this, which is the
What would you like to do?
Why did you? Oh, you restarted because I just turned the transmitter on. This is the remote of death. This has got a propeller stuffed in it and a nice touch screen. USBs for the screen and the prop. PS2s for keyboard and mouse. Video out on the back. A net server, infrared in and out, and video out as well. Not to mention a old school Nintendo plug for old school Nintendo video games that can be played through it as well. But I'll show you one of Walter's games here. I'll click games.
Shall we play a game?
And I'll click yes on the touchscreen.
Would you like to play rock, paper, scissors?
Yes again.
Ready? 1, 2, 3, shoot.
And I'll go ahead and hit rock for my selection.
I choose scissors. You chose rock. You have won. This game is rather silly. I am going to do something else. Main. What would you like to do?
And then of course just a host of other goodies, onboard chargers, et cetera, et cetera. He's chain drive. I ended up having to make most of the sprockets myself because I couldn't find enough bicycles, and I don't have a machine shop or anything. I just used an angle grinder and a Sharpie and just kind of worked at them until they were right. A labor of love, but he's sort of in the place I want him now. So
very cool. Will will he be making any public appearances at any events or anything anytime soon for people to check out?
Actually, yes. Hopefully in one of the upcoming Make the latest in robotics videos, he will be featured. Maybe
great.
not this coming Tuesday, but in the next few Tuesdays, I think.
That's cool. Do you take him out for walks? It sounds like he'd be really cute to like take out to the park and kids could pet him or something.
Well, you know, I tell you, yes, of course. I do teaching. I do, you know, I try to turn kids into nerds. And he's certainly, you know, the cool robot. But the goal actually is to get him to be a dog, where I can leave him on all day. He can charge himself. He can sit around. He can get bored. He can find something to do, you know, et cetera, et cetera. But more so, he's just a culmination of sort of everything I've learned. I mean, I was making an LED blink, you know, 2 or 3 years ago, and Walter's sort of the culmination of every little thing I've learned along the way, and continues to expand. It's just a never-ending project.
Very cool. Well, thank you so much, Chris.
Okay.
We're going to move on to Benjamin Latner. Show your project.
Okay. Hi, I'm just a high schooler. I'm going into college, but I find all this electronic stuff really cool, and I'm happy for your help, so here I am. My project is really simple, but I was just happy when I got it to work. It's just an Arduino with a piezoelectric buzzer and then a potentiometer, but I'm running the piezoelectric on my own. I'm not using a tone function or something like that. So here, let me plug it up.
Oh, cool.
It's quite simple. But I just wanted to show it because I ran it on my own. I'm pulsing power to the pin of the piezoelectric on my own instead of using some kind of special function that does it on its own. Which was just cool for me to be able to see how I can run a piezoelectric and know that that's how it works. And I had recently learned in physics class of how sound works and stuff like that, and how you can just repeat a simple mechanical sound really fast and it will make a tone or a function. So, yeah, like a frequency. So I have a blog that I'll link to it, and I wrote up more about it, and you can see the code where it's simply just turning it on and off for specific time that it gets from the potentiometer, and then when it does that fast enough, it makes it sound. So it's simple, cool. But I thought it was kind of cool to be able to learn make that work.
The next thing you should do if you want to expand your knowledge and mix it up a little bit is piezos are also usable as microphones, very basic microphones and beat detectors. So you might want to look online for op-amp schematics to use the piezo as an input, not just as an output. And then you could do some interesting stuff where you're not just driving piezo, but learning how to read from it, which is a little more difficult. But if you have the parts, you know, you could go to Radio Shack and even probably pick up an op-amp.
Sure, that's a good idea. Thanks.
All right, cool.
All right, moving right along. We're going to try to get to everybody. All right,
sure.
This is a scary one. I am anonymous. I'm sure that's your real name.
Hi, I'm Martin.
What are you going to show us?
I'm Martin. I'm from the ATX Hackerspace, and I've been working on a Atmega 328P based board. This is called Hack the Badge. It's basically an AVR learning platform, and it's got just about enough on it so that you can learn how to play and create games. So it's got a little 3x5 display, enough hardware on it, and it's a battery-powered Arduino. So, well, or near Arduino. So with the this particular processor, it can run for about 3 days on these two CR 2450s. So it's not too bad. It's a lot of fun.
This is really cool. This is what everybody wants. So badge hacking and making your own badges for conferences or events, everyone keeps reinventing it, and it's cool to see this as a platform. And I like that it lasts for 3 days, because that's pretty much about the amount of time that, you know, a conference will last the most.
Did you make this for your
Oh, go ahead.
Did you make this for your hackerspace or an event, or is it just like you just wanted to build it?
This was actually designed for DEF CON.
Oh.
Oh, great.
It was meant for the DEF CON Hack the Badge contest in 2009, and it's continued to exist as a learning platform ever since. So I use it at my hackerspace to teach other people about how to, not so much how to program Arduinos, but how to build platforms on generic microcontrollers, in this case, the Mega 325.
This is really cool. Could you post a link either on Google Plus or wherever else later, or email us if you ever publish any of the stuff online?
I just published it to the chat, and I'll go ahead and put it on my stream.
Oh, great. Well, thank you so much. This is really cool.
You're welcome.
Okay.
Thanks.
All right, we're going to keep moving
Cool.
on as fast as we can here.
Next up,
Eric Hall?
Eric Hall. He's got Blinky again.
Ooh, piezo buzzer. Oh, wait, let me turn off the mic.
No Blinky. This is more serious. This, here we go. I see you guys leaning in. You got all that?
Yeah.
We got an Arduino over here. You can't see it. It's under a step up. In the middle, you will recognize the solar LiPo.
Yep.
On this side, we got a Fez Panda.
Yep.
Big honking battery. And a VFD. So I can see the stuff in the daylight. Basically, on the outside is a panel. Woohoo!
Oh, wow.
Yeah. So on the inside, I'm getting voltage from the battery, getting voltage from the load, which would be the Panda and the Arduino, getting current from the panel, voltage from the panel, sticking it on the screen, logging it to an SD card, and I'm also doing comm between the Arduino and the Panda for the display, because next rev is going to be a couple of XPs so I can take the display somewhere else.
Oh, cool.
Yeah.
And what are you using this for?
I'm just playing around with solar. I'm pretty darn close to putting some solar on my house. I'm up in Vermont, and the state has finally got around to giving us some good breaks. So this is my sort of learn about solar before I buy solar project.
Yeah. Start out small. Put it on a doghouse or something first.
Yeah, exactly. This thing will run a phone or a Arduino, which is awesome. But it's more about logging some numbers and seeing what kind of sunlight will give me for current, et cetera, et cetera. The cool thing is I can take out the SD card and it's just comma separated data, and I can slap it in Excel and make some nice charts and
Yeah.
See what the difference between a cloudy day and a sunny day is. Today I put a temperature probe on the battery because it got pretty hot.
Yeah.
It was about 90, and got a little nervous.
Yep.
So that's on there now, but I'm having fun with it. And oh, I forgot to mention, it wouldn't be Adafruit without the Minty.
Yeah, that's true. we have to pay Altoids soon for all the.
Right. I had a hard time finding it.
They have to pay us. Sorry, yeah, it goes the other way.
There it is. It's fun. It's good. It's practical. It's not blinky.
That's okay. That's cool. I like the Trapper Keeper for the waterproof enclosure.
Yeah.
Oh, this is a little thing I stole from the office. It's awesome. It's not quite waterproof, but it certainly helps, and it even snaps closed. Ooh.
Very cool. Okay, we're gonna move on. Let's see. We've got Scott Robarts.
Yeah.
Oh, sorry, guys. I'm just watching to see what
Just watching?
everybody's.
All right.
All right, next time you have to bring a project. Project's required to be part of this party.
Yeah, it's like Fight Club. You have to fight next time.
Okay. Next time I'll bring something.
No problem. All right, Chris Cartwright, what do you got?
All right. Can you hear me?
Yep.
I have what I call Ryder Net. It's a second component of the Ryder track system.
Wow.
It's it's a wireless router with an Arduino Mega built into it, so as a sensor and control platform, the wireless router, the Arduino Mega Ethernet shield, a VFD display, and then 4 sensors, an internal and external sensor, because these are all going to be going outside, an oil level sensor, because this whole thing is going to be bathed in mineral oil to provide temperature stability and control in all weather conditions, and an aquarium heater and pump to keep the oil flowing and whatnot. And the Arduino controls the power. There's a power switch tail underneath, so that if the oil drops out because somebody shoots it or or if it gets too cold or too hot, the Arduino will shut the router down and save the router from frying itself. So it's a combination of 4 different sensors on a Mega platform because I need the memory all wired together. And I've built 6 of these, and in the future I'll show it in the mineral oil enclosure. This is a little flex sensor with a piece of styrofoam and a horse, so it'll float in the mineral oil. And if the oil leaks out, the sensor falls and it triggers the alarm. This is how I'll provide wireless networking to a horse farm and have them mounted on trees and in tack rooms and places where you normally couldn't put equipment like this. But it's all Arduino control and all Adafruit stuff.
Wow.
Why do you need the mineral oil again? What needs to be cooled off?
Temperature extreme. So the equipment inside of it, like if it gets down to minus 20 degrees, minus 30 degrees in the wintertime, if it's covered in snow or ice, or if it gets up to 100, like if it's 115 outside here, the router inside will be so hot it would stop working, and the oil will stabilize the temperature of all the different components.
I like that you thought about the equipment getting shot. Not a lot of people think about what happens if their project gets shot. So.
Yeah, that's the country, so, you know. But, but the
Very
VFD
cool.
is nice because it works in the mineral oil. Anyway, thanks.
Thank you so much, Chris. All right, we're going to keep moving along here. We've got someone who just popped in. Andy, I think you wrote earlier that you wanted to go last. It might be you. You there, Andy?
Yeah, I am here. Can you hear me?
Yeah.
Yeah, I mean, basically, my web server just crashed.
No.
It's okay. I mean, I just got your camera the other day, so I went ahead and hooked it up, put it on an Ethernet shield, and go ahead and I have it writing images to it, and it's actually a little web server and can actually either serve it or also push these images someplace. I'm actually right now. This is from your camera.
Wow, so you're doing the Google chat over our little JPEG camera.
Yes.
Wow. I don't even know what you really. So what did you have to do to get it to work as a web camera?
I just hooked it up to a USB video capture. You know, standard video in to a video capture device, and I'm bringing it in that way. Just you know, wired.
It's NTSC out, so you can.
Yeah.
It is a little bit not color corrected.
Yeah.
But it's, you know, it's good enough for security stuff.
Yeah, it's not perfect, but I could actually probably fix that. But
very cool.
So that's it. So it works pretty well. I downloaded all the stuff from you guys, and it's working pretty good.
That's great. I like that the first thing you did is use it in a way that we didn't intend. Thank you.
Well, of course.
Yeah.
Okay, cool.
All right.
Okay,
So,
that's it.
I'm gonna see if we could squeeze. We've got 2 more folks that are here, and we'll try to get them in. JP.
JP.
Yeah.
All
So
right.
I saw you lowered the price on your VFD,
Yes, we did.
but I wanted to show the VFD I got on eBay.
Wow. Nothing. It's big.
And so I made it into a clock. Got on a Arduino with your breakout for the clock.
Oh,
real-time
cool.
clock. But yeah, it's a really big one.
Yeah. Did you have to do anything different, or did the code just work? I mean, what
So
did you have
this
to?
one uses the Hitachi LCD protocol, and I used the LCD liquid crystal library.
Yeah.
But I had to slow down the delays because it runs a little slower.
Oh, gotcha. These displays are really beautiful. You have to see. I think for folks who haven't seen it, if you see them in person, they're really bright.
And this one uses just 5 wires. It's kind of SPI, but not really.
Yeah.
It's actually it's multiplexed. And there's a library out for this one. This one's from Prime Electronics.
Oh, cool.
This was like $3 or something for this huge thing.
Wow. And are you going to make an enclosure? Is that the next step for the clock?
For the clock, I'm just going to use a wood enclosure and then like smoked plexi on the front.
Oh, cool. Yeah.
Laser cut that, and then I'm just going to use a Ethernet Arduino or a WizNet module to get the time off NTP server.
Oh, good. That's great. Well, when you're finished, send us an email or some links. This is a project that everyone likes to to build, and clocks are really popular.
Right.
Okay, thank you, JP. Very cool.
Awesome.
Every week there's a clock project. Okay, next.
Final person.
Probably final, yeah.
Peter.
Well, we might try to squeeze through 2 more, but let's see. All right, Peter, go ahead.
Hey, what's going on, guys? Real honor to be on here with you guys. You're my heroes. This is the air harp right here.
Oh, great. We were talking about that.
Yeah. So basically, it's just a USB MIDI controller. It's just an Arduino Uno with a little shield that I designed on top. It's got an ultrasound and just 5 push buttons, and you can select up to 15 different chords. And then when you, how am I going to do this though? If I unplug my headset, it's going to feedback, isn't it?
Well, let's see what happens.
Okay.
What's the worst that can happen?
Can you hear that?
Yeah. This is how my species communicates.
I use a narrow divergence LED on here so you can see the dot on your hand, and it kind of tells you where the ultrasound is aiming at. And you can play most songs on it. I think it's pretty handy.
Yeah, for the folks who are interested, stop in the Adafruit forums, and Peter's talking about selling kits and starting a business and doing all sorts of stuff with this. So stop in and encourage him. I think this is a really cool kit, and it would be neat to see out in the world. And you open sourced everything too, right?
Indeed.
Very cool. All right, Peter. Well, we're going to try to squeeze in one more person, but thank you for showing this, and we'll do a follow-up post on our blog maybe next week after we read the forum post and see what eventually you're going to do.
Yeah, we have some ideas to make your project good, but we have to cook in our brain.
We think we can help you make it cheaper.
Very cool. I'd love to hear that.
Yeah.
Thank you.
Okay, and then let's see.
We did Andy.
We already got Andy, and then I think we got through everybody.
Yeah.
I think that was it.
All right.
Okay, look at this. He's got something in here.
Yeah, that's the camera with the camera.
It's Andy looking at Andy looking at Andy. All right, that's the Adafruit camera. All right, everyone. Stop back on Ustream in just a few minutes. We will be starting Ask an Engineer. Thank you to everybody who came out tonight. This was a lot of fun. Cool projects.
Next time, everyone have a project, show up with a project so that we have lots of stuff to show.
Yeah, next time I'll figure out how to use Google Hangout better.
Yeah, we're still learning. All right, bye everybody. Be right back.